After today, you will know everything that you need to know for the exam. Wednesday will be a review session, so bring in any questions. Oh yes, the exam review packet is already up online. So if you want to prep for this Sunday exam review session with that, you can download it now. They will also have them there. Last class, I talked about going from volume of a reactant to grams of a product. Today we're going to go from volume of one thing to volume of another. So we're not going to use molar mass in this case. So for example, I'm going to use this. I like this example because it has solutions, but it also has a precipitate. But we're not going to talk about the precipitate right now because I'm going to ask you to figure out how many liters of one thing you need to react with liters of another. How many liters of 0.192 CaCl2 are needed to fully react with 0.956 liters of 2.9 molar Na3PO4. And there were a lot of questions about molarity in terms of how you do convert that into a conversion factor. Oh, sorry, that's 0.192 molar CaCl2. There you go. And so that 0.192 molar is equal to 0.192 moles over 1 liter, okay? So when you have the molarity, that number there is always the number of moles of the solute, and it's always per 1 liter of solution, okay? So if you flip that, you're gonna end up, if you wanna go from moles to liters, you're gonna flip it and you're gonna have 1 liter on top and the 0.192 moles on the bottom. So I just wanna make this clear that this is how, if you are turning this into a conversion factor, this is how it's gonna look. And you can also flip it upside down. So I'm going to go from liters of Na3PO4. In this type of question, you start with what you have the most information about, okay? What we have the most information about is the Na3PO4 because we know the liters and we know the concentration, okay? We only know the concentration of CaCl2 and we're trying to get the liters of that, so that's going to come last. You're going to start with what you know, the molarity and the volume of. So I'm going to go from liters of Na3PO4 to moles of Na3PO4 to moles of CaCl2 to liters of CaCl2. So 0.956 liters of Na3PO4. And what am I going to use to convert to moles of Na3PO4? .9 molarity, yes. So for 1 liter of Na3PO4, 2.9 moles of Na3PO4. How do I convert that to moles of CaCl2? Molar ratio, which is 3 moles of CaCl2 to 2 moles of Na3PO4. What's my last step? convert back to liters. Now, what do I have to do with this? What am I going to do with this? How am I going to use this as my, I'm going to have to, yes, but I'm going to have to flip it. So I want moles on the bottom, so I'm going to put 0.192 moles on the bottom and 1 liter on the top. Which will give me 22 liters of CaCl2 solution. Any questions on that? Which actually sort of makes sense because I have a pretty low concentration of my CaCl2 and a very high concentration of my Na3PO4. So you're going to need more of the low concentration to mix with less of the high concentration, okay? Does everybody have this down? No? Okay. It's 0.192 moles of CaCl2 down there. I can see. Okay. Sometimes I won't ask you for the number of liters. Sometimes I'll say, oh, I mixed this many liters with this many liters, this concentration. What was my other concentration? So in this case, it's going to be a slightly different conversion because we want to end with moles over liters. If I'm asking for molarity, I want to end with something over something else, okay? I don't want just liters. Don't want just moles. I want moles over liters. An example of this, using that same reaction, if 1.2 liters of 0.45 molar CaCl2 is needed to react with 2.9 liters of Na3PO4, what is the molarity of Na3PO4? So I'm looking to end with moles per liter. I'm going to start out like we normally do. I'm going to start out with 1.2 liters. I'm going to start out with what we know the most about, which is the CaCl2, because we know both the liters and the molarity. So 1.2 liters of CaCl2, and then 0.45 moles of CaCl2 per 1 liter. I'm going to use my molar ratio. 2 moles of Na3PO4 to 3 moles of CaCl2. What's the problem here? Why am I not just going to multiply by the amount of liters? We don't want to get rid of this. And we need liters on the bottom. So what I would recommend doing is stopping here, determining the number of moles, then dividing by the liters. So you get 0.36 moles of Na3PO4. Now I'm going to divide that by 2.9 liters. Now, it is possible if you know how to do a placeholder 1 and divide by liters, you can do this all in one conversion, but that tends to confuse a lot of people. What I would recommend is just finding the number of moles and then dividing, because what the tendency is like, well, what do I go from here? I'm going to multiply by something else, but you can't do that. You can't multiply by liters because we want liters on the bottom. So you have to divide by liters. Always think about your units. You want to end with moles on top, liters on the bottom. Any questions about that? This, if you go on in chemistry, you will use this a lot in lab with something called titration. Okay, so titration is done to determine the concentration of a particular solution, generally an acid or a base. Okay, and what we're going to do is, so basically what you do with a titration is you have a certain volume of an unknown concentration. Say that's the acid. Then you add a known concentration of base, keeping track of how much you add, until you reach what is called an equivalence point, which means that the moles of OH minus equal the moles of H plus, right? Moles of acid versus moles of base. And at that equivalence point, there is some indicator. Sometimes it's a pH probe. Sometimes it's something called phenolphthalein, some color indicator that indicates a change in pH. What you need to know for this class is that sometimes I might ask you about something that titrates something or neutralizes. It just means fully reacts with. So an example of this type of question would be, so you've taken 16.8 mils in a beaker, HCl, and you've added CaOH2 until you've reached your equivalent point. And you see that that is, and you know the concentration is 0.5 molar, and you see that you've added 22.5 mils. From this, you can say, okay, I can determine the HCl concentration. And it's going to be very similar to the problem I just did in that you have to stop, find the moles, and then divide by your volume. So you have 22.5 mils. What do I have to do first with this? Change it to liters. So 1,000 mils per 1 liter. And now I have 0.50 moles of CaOH2 per 1 liter. My molar ratio is 1 mole of CaOH2 per 2 moles of HCl. And that's going to give me 0.0225, moles of HCl. How many sig figs do I have? Why do I have 2? The 0.50. Yeah, right here. The 0.50 has 2 sig figs. So I'll keep my sig figs, but I'm just going to underline them so I know that I have only 2 sig figs. So my answer later on will be limited by that. Now I'm going to divide 0.0225 moles of HCl over, what's the problem here? It's not in liters. I have to convert my 16.8 milliliters into liters, which you have to divide by 1,000. So it's 0.0168 liters. And finally, because we have those 2 sig figs, it's going to be 1.3 molar HCl. And you've just determined your concentration by titrating with calcium hydroxide. Any questions on that?
If you ever write
So I had it in 16.8 mils. If you convert that to liters, it would be 1,000 mils on the bottom per liter, would be 0.0168 liters. I just didn't show that calculation. You just need to be very clear that you have everything in liters because it's moles per liter. I would like you to balance this and then answer the question. And if you have any questions, raise your hand.
Wait. No, we can, yeah, we'll start with same thing. Yeah. Yeah, okay, that is.
All right. What do I start with? Liters of H2SO4. So, excuse me. 0.29 liters of H2SO4. What do I use next? The 1.0 molarity, so 1.0 moles of H2SO4 per 1 liter. Now, what's my molar ratio? 2 moles of KOH per 1 mole of H2SO4. So that's my number of moles, and I have, well, how many moles do I have? 0.58, thank you. Moles of KOH. And what's my last step? Divide that by 0.75, and my answer will be 0.77 molar KOH. Any questions on that? Okay. Moving on. Your homework is going to have your online homework has some questions that I haven't specifically addressed, so I'm going to address those now. It's kind of like how you would prepare a solution. And by that I mean questions like how many grams of NaCl are needed to make 1.0 liters of 0.929 molar NaCl solution. So what I'm asking here is, if you were in a lab and you had to make 1 liter of 0.29 molar NaCl solution, how much NaCl would you weigh out, you know? So what we're going to do is we're going to go from liters to moles to grams, okay? So we're going to take 1.0 liters of NaCl, and for every 1 liter, we have 0.29 moles of NaCl, and then my molar mass is 58.44 grams per 1 mole of NaCl. And that gives me 17 grams. The reason I'm having you do answer these types of questions on your homework and on your test is because if you go on in the sciences, you will have to make solutions. So you will have to weigh out salts and solubilize them in water and make a solution of the correct concentration. So what I'm saying here is that you weigh out 17 grams, you dissolve it in water, and you make that level of the solution go up to 1 liter. That means you have 0.29 molar NaCl. Okay. Another question I might ask you, which I would like you to do, is how many liters of 0.85, I thought it was one of you guys talking to me, 0.854 molar CaOH2 can be made with 29.2 grams of CaOH2. Please figure that out. 29.2 grams of CaOH2. Yeah. Yeah. All right. So basically, you went back in the opposite direction. So you start with grams, and you're going to go back to liters. What's my molar mass for CaOH2? 74 point per 1 mole of CaOH2. Now, what do I do with that molarity? 0.84 on the bottom, 0.84 moles of CaOH2 per 1 liter. And my answer is 0.47? 47, 2 sig figs in 0.84, so 0.47 liters of CaOH2. If you ever want a job in a lab, you have to be able to do this. No, thank you. All right. One last thing I want to cover in terms of type of problem. It's called solution dilution. Solution dilution is simple, which means people try to use it too often. Okay, there are only certain situations that you can use this formula, and it is only when you are diluting. Okay, so what do I mean by that? What is dilution? Making something less concentrated. Yes. And how would you make something less concentrated? Add solvent. Yes, exactly. So you want to decrease the solute concentration by adding solvent. That is dilution. Okay. So our formula for solution dilution is C1V1 equals C2V2. And the C1 is concentration of your initial solution. I learned this in high school as M1V1 equals M2V2, same thing. And then your V1 is your volume of your initial solution. C2 is your concentration of your final solution. And V2 is your volume of your final solution. You can only use this, basically you can't use this in a reaction. If you're going from one compound to another compound or one substance to another substance, you cannot use this because this does not take into account your molar ratio. You can only use this when there are some keywords that I will use. Dilution, diluted, final solution, final concentration, stock solution. Those are all keywords for when to use this. So stock solution, generally people, when you order chemicals, you order them in a highly concentrated form because that means there's less volume and it's cheaper to ship, okay? But most people don't need 12 molar HCl. So when you want to use HCl, you take the stock solution, a little bit of it, and you dilute it to the concentration that you want. So I can give you a question like this. I have 12 molar HCl stock solution. And I need to make 5.00 liters of 1.50 molar HCl. How many liters of stock solution do I need? What's my C1? My initial concentration is 12 molar. What's my V1? We don't know. That's what we're figuring out. So I'm just going to put V1. What's my C2? 1.50 molar. What's my C2? Sorry, that's my C2. What's my V2? 5.00 liters. How would you solve this? Yeah. Multiply, divide. How many sig figs should I have? 2. B1 equals 0.63 liters. What this means physically is that you would measure out 0.63 liters and you would add water up to 5 liters, and that means that you would have 1.5 molar solution. Any questions? Mostly, very commonly, you will see molar and liters here, but it doesn't actually matter what the units are as long as they're consistent on both sides. Okay. So if I give you a question like, how much 2.0 molar NaOH is needed to make 10.0 mils of, sorry, that's 10, of 0.5 molar NaOH. What's my C1? 2.0 molar. What's my V1? We don't know. What's my C2? 0.5 molar. What's my V2? 10 mils. So that means that your V1 will be in what unit? Milliliters. So it doesn't have to be in liters all the time, but if you have milliliters here, your answer is going to be in milliliters. So you do the same math, and it would be 2.5 mils. I would like you to do this question. Oh, sorry, that's the question I just gave you. I would like you to do this other question. One 1.8 liters of 2.9 molar NaCl is diluted to 9.5 liters. What is the final concentration? Please figure that out. One more question that you want to stay for. What's my C1? 2.9 molar. What's my V1? 1.8 liters. What's my C2? You don't know. What's my V2? 9.5 liters. So what is my C2? 0.55 molars. Excellent. So only use this during dilution. And I cannot, like, that's just such a common mistake. Don't use this if you have one reactant going to something else or a reactant going to reactant. Yes, Eleanor.
What exactly do you do? I got set up to that point, but then I don't know what I do with what.
Multiply these two. Then divide by that. Okay. Yeah. Because you want to get C2 by itself, so you have to divide. Now I want you to combine a solution dilution with solution stoichiometry. Okay? So first step is to balance this, and then oh, 1 molar, sorry. Thank you. So first balance it, then answer this question. 12 mils of 1.0 molar NaOH is diluted to 25 mils. How many liters of the resulting solution are needed to neutralize 19.8 mils of 0.59 molar H3PO4? It's a two-step problem involving both solution stoichiometry and solution dilution. If you need help, raise your hand. Mm-hmm. Here's a hint. The first sentence and the second sentence need two separate calculations. The first step is not reaction because I'm diluting. Look out for those keywords. Is that a hand?
Yeah. So I'm just a little confused because in this one I'm going milliliters to liters. Am I doing it right now?
So what's your step here?
So you're gonna molarity.
Oh, you need those polarity. In which polarity are you?
You go to that, right?
You're trying to get liters, you're going to use, yeah, you're going to start
You want it to, and then you go to.
No,
No.
use your molar ratio. This is probably the hardest type of problem that you will have on the test. But there will be a problem like this on your test, maybe two. Do you have a question? Just one you want? Just one problem, please. All right. No, not yet? Okay. Few more.
So now, are we doing them?
Let's divide all of these by. The resulting solution is the resulting concentration from this
So we have the first part. We have the first part.
Okay, that's what I was wondering. Is that how? So just that. Cool.
I'm going to go over this. My first step has the word diluted in it, which means it's what? Solution dilution. Okay, so your C1 is 1.0 molar, and your V1 is 12.0 mil, and your C2 is unknown, and your V2 is 25 mils. You should get a you should get a C2 of 0.48 molar NaOH. That's the resulting solution. Okay? So now you're done with this. If it helps, once you figure this out, to cross out that sentence and know that you're done with that part of the calculation, do so. So even though we found the concentration of NaOH, we still know more about H3PO4. So first we're going to deal with H3PO4. We're going to start with 19.8 mils. What do we need to do with those mils of H3PO4? Change them to liters. Okay, so we're going to have 1,000 mils per 1 liter. Now what do I use? 0.59 moles of H3PO4 per 1 liter. What's my next? Oh, sorry, I forgot to balance it. It's 3 and 3 up here. What's my next step? Molar-mole ratio, which is a 3-to-1 ratio, 3 moles of NaOH per 1 mole of H3PO4. Final step. Use this molarity that you found. 0.48 moles of NaOH per 1 liter. I ran out of room, but I'm going to put my answer up here. What's my answer? Is that what everyone else got? No. What did anyone else do this?
0.07.
So 0.07. Okay, I got a confirmation. 0.078 liters. That's your answer. Oh, 7.3. Sorry. Sorry, I made this question up during class last night, so I never actually did the calculation.
Chris tries to give me the study problems. He's like, I don't know the answer.
Yeah. I will see you on Monday.